This is part 2 of our graphing rational functions. So we're on step 1 again. We're going to factor what we can and then cancel anything that we have to. So if we factor the bottom quadratic, we get x plus 2 and x plus 1. Now when we cancel out the x plus 2's on the top and the bottom, it will leave us with just 1 on the top and x plus 1 on the bottom. Just because you canceled something out doesn't mean it's gone forever. It just means x plus 2 divided by x plus 2 is 1. Well, 1 is still on the top of your fraction. So this is what we're going to be using to find out our information for the next couple steps. Okay, so we have 1 over x plus 1 as our equation. First thing we're going to do is we're going to plug 0 in for the x's to find the y-intercept. So if we do 0 on the bottom, we get 1 over 1, which is just 1. So our y-intercept is going to be 0, 1. So we can plot that point on our coordinate plane. Step 2, find the x-intercept. So remember, we don't care about the denominator of our fraction right now. We're just looking for the numerator, and if our numerator is 0 equals 1, well, that's not true. So because that's not a true statement, there is no x-intercept. And this is a telling piece because we'll find out in a little bit why there's not going to be an x-intercept. So the graph is not going to cross through the x-axis, okay, because 0 does not equal 1. It's not a true statement, okay? So moving on to step 4, find the vertical asymptote. So we take our denominator, we set it equal to 0, and we solve for x. So x equals -1. So we take our vertical asymptote and plot it on the coordinate plane at -1. Remember, again, it is a dashed line. Okay, dashed lines in math, when you put them in there, that means that you don't actually see them as part of the graph. So if you were to graph this in my calculator, for example, it would have the dashed line in there, but you wouldn't be able to see it. Okay, it would be invisible. Step 5, our horizontal asymptotes. Okay, now if you've been looking at the part 1 of this video, you'll see that there's a bunch of stuff that's listed on this particular step 5, and we have kind of ignored it for the most part. But right now we're going to show you why we're not going to ignore it anymore. Okay, so your horizontal asymptote, we kind of alluded this in the first video, part 1, is trying to figure out what happens to the graph as x approaches positive or negative infinity. Okay, so what we're actually doing is when we take the leading coefficients, we're going to have 1 over x. So we're going to take x and assume that it's a really, really big number. Just say like a trillion. In this case, we're going to do 1,000,000. So 1 divided by 1,000,000. Well, that number is going to be really, really, really small. Okay, it's practically 0. So what we're really doing when we're doing all this stuff is we're putting big numbers in for x's and seeing what happens. Okay, well, in the other 2 examples that we had in part 1 of this video, the x's would cancel themselves out when you divided them because there was an x in each piece. Okay, well, in this case, there's no x on the top of our fraction. There's just a 1. So when we put a really big number in for x, like we would have done in the other places, it would have just reduced to be the numbers that we've gotten. But in this case, 1 divided by 1,000,000 or 1 divided by -1,000,000 is going to be a really small number. It's going to be really, really close to 0. So that's what we're going to say our horizontal asymptote is. When you have 1 over x, it's going to be really close to 0. So that's what we're going to write our horizontal asymptote is going to be, y equals 0. Now this also explains why there was no x-intercept. If your horizontal asymptote is on the x-axis, there's not going to be an x-intercept. Okay, there's not going to be a point that the graph's going to go through on the x-axis because there's an asymptote there. Okay. All right. Step 6. All right. Are there any holes? So we did cancel something out. If you remember from the very beginning of this, we had x plus 2 that got canceled out. That means if we take our canceled factor, x plus 2, and set it equal to 0, and solve for x, we'll get -2. So -2 is going to be the x value of our hole. You then put that value back into the equation for x. So if you put -2 plus 1 on the denominator, you get -1, and 1 over -1 is just -1. So that is going to be our whole point, which is negative 2 comma negative 1. Again, make sure you're drawing an open circle for your hole. All right, again, all your points are from the origin of the graph, not from the intersection point of the two asymptotes. So that can be confusing when you're just looking at everything with all the different lines you might get. So from the origin, going left 2 and down by 1 is where your hole is going to be. All right. Step 7 is the sine analysis. Figure out where the other points are going to be. But in this case, both sides have a point. Okay. There's a point to the right of the vertical asymptote and a hole to the left. So you don't need to find another point. You can just use those 2 points as the points for your graph. So then we graph that using the rules of the asymptotes and going through the point or hole, making sure that you don't actually go through the hole. You just go, you kind of just jump over it. Whereas the point, you go through the hole for the graph. And that is the graph for our question number 3 in the notes. Last one. Again, we're going to factor and cancel if possible. So we can factor this problem. Here's the factorization. You have x plus 4 and x minus 1 on the top. Then you only have to take out an x on the bottom, and you're left with x plus 4 on the bottom as well. So that means the x plus 4's can cancel out, and we're going to be left with x minus 1 over x as the equation we're going to use to find all the other information for our graph. So step 2, find the y-intercept. Again, we're using x minus 1 over x. We're going to plug 0 in for the x's. All right, and this is going to have a problem because it is you notice there's a 0 on the bottom, and that's it. You can't have that in math. That is an undefined answer, which means there is not going to be a y-intercept. Okay, so there's no point because, as we saw with the previous problem where there was no x-intercept, it's probably because there's going to be a vertical asymptote on the y-axis. Step 3, the x-intercept, plugging 0 in for y and solving for the numerator. So we have x minus 1 equals 0. Solve for x, you get 1. So we're going to put this as a point, 1 comma 0, and plot that point on our coordinate plane. All right. Next, we have the vertical asymptote. We take our denominator, set it equal to 0. Well, it's just x equals 0. So that is our vertical asymptote. And that does mean that kind of explains why there was no y-intercept, because your horizontal asymptote is on the y-axis. Again, it's a dashed line, so you can't actually see it, but it's that boundary you can never cross. For step 5, you're finding the horizontal asymptote. So we take our leading coefficients, so it's x, and x divided by x is just 1. So our horizontal asymptote is going to be y equals 1 with our dashed line. Next, we find out the holes. So if you remember back to our first part of this equation, we cancel out x plus 4's. So we take our factor of x plus 4, set it equal to 0, and solve for x, which will give us negative 4. We then take that value, put it into the equation. So we get negative 5 divided by negative 4, which is positive 5 over 4. And that is our hole. We put our graph our hole, again making sure it is an open circle. All right, and last but not least is the sine analysis. Well, we don't have an unknown area because there is both sides have a point on either side of the vertical asymptote, so we don't need to find another point. So we can just plot our graphs as long as they don't go through the hole and don't go through the asymptote. And there's our graph. All right, that is 4 different examples of graphing rational functions through those 2 videos. Please, it's very important that you practice these problems. We're going to spend a lot of time on this. I want you to get help if you're having problems. It's okay if you're struggling a little bit, but reach out in a Zoom or go to office hours or something to get help in trying to solve these problems. Good luck.